For this game, each player is given a score S, where S is a real number. Based on how many attempts it takes to then get the words. In Ireland, the player scores are approximately distributed from the mean. It takes an average 3.87 guesses to get the right answer, and a standard deviation of 0.36. A player is selected at random and from the players in Ireland. Find the probability that this player has a score of less than 3.5. Okay, so probability of a score less than 3.5. Agreed? Now, what we're taking is 3.5 is below average. Would you agree with that? Because average is 3.87. Okay, so 3.5 would be around here somewhere. So what we're asked for is the size of this area here. And the size of that area there has to be smaller than 50% because you're below average. That makes sense? Okay, so here's what we're going to do. We're going to use a standard set score. We're going to use set score equals x minus mu all over the standard deviation. We're then going to put in 3.5 as our score. Take away 3.87. And then we're going to do 3.87 over 0.036. We're going to get a set score of minus 1.03. So this diagram now changes into a set score of minus 1.03. Now, when you go to set scores on your tables, they only give you positive numbers. They do not give you negative numbers. 1.03. Is that okay with you guys? So how do we get this? Well, to me, see this red area here? Being bigger than 1.03 is the same thing as being smaller than minus 1.03. Does that make sense? I then go to my set scores and I read off what a set score of 1.03 is. I'm going to read off that set score. It's going to give me 0.8485. This is to indicate that 84.85% of the population has a set score below 1.03. So if I do 1 take away 0.8485, it will tell me what's in this red zone. As we discussed earlier, that red zone is the same as that blue zone. So we should be able to get the answer that way. And the answer when I take that away is 0.1515. A random sample of 64. It's a sample of, it's not one score, many scores, yeah. Has a mean score of 3.74. Based on this, a local newspaper claims that Galway papers have a different mean score for players in Ireland. Construct a 95% confidence interval. See the 95% confidence interval? It's your mean plus or minus 1.96. Why is it 1.96? Can anybody tell me? Because in set score terms, scores between 1.96 and minus 1.96 contain how much percent of the population? 95% of the population in between those two functions. Now, what's the standard deviation or standard error we're going to use? Because it's no longer the standard deviation, because you have 64 players. So it's going to be over the square root of 64, or root n. Okay? And all you're going to do then is you're going to do 3.74, which is the Galway average, plus or minus 1.96, 0.36 divided by root 64. Okay, we got to do both of them. So it's going to be a U value. We're claiming that the average for the population in Galway, when we take it away, we get 3.6518, and when we add it on, we get 3.8282. It doesn't ask us to do anything with it, does it? It just asks us to get it. Would that make sense? Any questions? Now, carry out a hypothesis test at the 5% level of significance, which means you can use the 95%. You can either use a set score, or you can use the confidence interval you just created, whichever one you want. Because we just did the 95% confidence interval, I'm pretty sure we should use that because we already have it made, don't we? Okay. So what we're going to say, what's the null hypothesis H0? What are we claiming? Okay, what's the mean of the players in Ireland? Is it 3.87? So what we're claiming is the mean is 3.87. And what's H1 claiming? The mean is not 3.87. This is literally from the marking scheme. They didn't really write much, but I usually write a bit more. The mean of players is 3.87. The mean of players is not 3.87. Okay, now what do we think about our confidence interval? Is 3.87 inside this confidence interval here? Is 3.87 in this range? That means 3.87 is it actually in the critical region outside the 95%. See the way it's not included? So what does that mean? Accept or reject? What you say? Yeah. So we reject null hypothesis. Okay. Galway players. So we say Galway players do take a different amount of attempts. Do take a different average number of attempts. Okay. Reason for my conclusion. What is the reason? 3.87 is not within the 95% confidence interval. Okay. The national newspaper conducts a survey on a random number of N teenagers in Ireland. 35% of the sample said they play the online word game every day. Based on 95% confidence interval for the percentage P, percentage is another fancy way of saying proportion. A proportion is a fraction. Percentage is a fraction multiplied by 100. Okay. It was calculated to one decimal place as 29, 26.5, and 43.5. Okay. Use this to work out the value of n. Well, tell you what, I'm going to change it to this because I don't like any deal in decimals, not percentages. Can anyone tell me what the mean would be? The mean has to be dead center. So what does that mean? Add them together and divide by 2. Add them together, you get 0.7. 0.7 divided by 2 is 0.35. Is that okay? But 0.35 was actually your test statistic. We actually already had that, didn't we? See that? Actually gave it to us anyway. But they don't have to give that to you because there's a way of working it out. Anyway, does that make sense? Now, it's the confidence interval of the percentage or of the proportion. Does anybody know the formula for that? Anybody know it? Haven't done this one in a while. And then there's this formula here, isn't there? What is it? P all over N. That's the one we're dealing with here. And your P value is 0.35. So it's going to be 0.35 plus or minus 1.96 square root of what, guys? 0.35 multiplied by what's a 1 take away 0.35, which is 0.65. Oh, the goal of the question is to find what? The goal of the question is to find n, isn't it? Now, have an idea. What we're going to do is we're going to highlight the gap. What's the gap from the middle to the upper section here? What's that gap, do you think? So take one away from the other. What do you think you get? Take the two yellows away from each other. Anybody? Huh? 0.085. This means your confidence interval, which is the blue part, is actually 0.085. Right, step one, we're going to isolate n on its own. What's step one? Bring the 1.96 where? Where are you going to bring that 1.96? Anybody at all? We're going to bring it under the 0.085. Okay, I'm not going to round off anything for a long time here. What am I going to do next? I'm going to square both sides, yeah? Okay, so square both sides. I'm going to get 0.35 times 0.65. Okay, I'm going to be lazy in a second. I'm going to put n on the bottom. And then on top, it's going to be, what's it, point? Wait 1 sec. You'll see what I'm doing, the different colors in a second. It's going to be 0.085 squared, and the other one's going to be 1.96 squared. Is that okay? Now, if you can just look up, because I'm doing this all in one go. So here's what I'm going to do. Where does that n go? Top right. Where does the purple bit go? Bottom left. Where does the green bit go? Huh? There you go. Just doing the right out again. All right. And you're going to throw all of that into the calculator, and you're going to get an n value of 120.963. 120 people is not enough to get it in this range, so you actually need 121. Even if that was 120.3, I'd still round that off to 121. You either have enough people to get it in that range or you don't. All right. Now here we go. A player wins a game if they guess the word of 6 guesses or less. The organisers of the game record the following statistics in Europe: 80% win the game each day. 90% of players who win the game will play the game the following day. 25% of players who do not win the game will play the game the following day. Some of the information shown is on tree diagram based on 360,000 people who played the game on June 1st. There's a lot of information there, and we're not going to use a lot of it, are we? The squares represent proportions. The rectangles label win, play, win, lose represent the number of people who play, win, or lose, respectively. For example, 0.8 of 3,600 people who played the game on July 1st win the game. Assume that for people who play the game on a number of days, winning the game on one day is independent of winning it on another day. Whoa, it's a lot of writing, isn't it? I think we'll just go in here and see what's going on for ourselves, right? 1st of June, you had only 360,000 people play. If 0.8 is you win, what must be you lose? 0.2. Okay? Now, 0.8 multiplied by 360,000 people. So I'm multiplying these two boxes by each other. I'm going to get 288,000. Is that okay? What about the bottom one? 0.2 by 360,000? 72,000 people. Is that right? Now, what's next then? 0.9. What's 0.9? So we're going to get our 288,000 people, and 90% of them are going to play. So what happens when they play? 90% of that is 259,200. Is that okay? And then multiply 72,000 people by a quarter, and we get 18,000 people in this zone here. And then we're going to go through. Now, the statistics are different for this one. The previous one was 0.8 and 0.2, but because we played the previous day, the statistics have changed. By chance of winning is now 0.9, Well, my chance of losing. Oh, sorry, I'm wrong. Sorry, I'm wrong. I'm wrong. They claimed that each day is independent, didn't they? Where's the language in that? Independent. So winning one day does not affect your ability winning the next day. So it's actually still point A and point 2. So that's still point A, that's still point 2, that's still point A, and that is still point 2. They actually gave us a hint there. Now, our winner one will be 207,360 because we're multiplying the 259,000 by 80%. We're then multiplying the 18,000 by 80%, which is 14,400. We're then multiplying the 18,000 by 20%, which is 3,600. And then on the last day, we're finding out how many people played. Well, I won the previous day, which means 90% of me will play it again. I lost the previous day. That means only 25% of the losers will play. I won the previous day. 90% of us will play the next day. Lost the previous day. Only 0.25 will play today. Put this into my calculator. 90% of 207,360. 186,624. 25% of 51,000 is 12,960. 90% of 14,400 is 12,960 as well. And the last one is 3,600 people. I get 25%, which is 900 people. And we pause. One person is at random from those who played the game on all 3 days. So you have to play the game all 3 days. The first, the second, the third. Find the probability that this person lost on the 1st of June or the 2nd of June or both. Whoa. All right. Now, how many players played all 3 days? It's the first thing. Here we go. So we're just going to highlight all of these numbers here. See all these numbers here? These are people who played on all 3 days because they've made it to the end, haven't they? So they played all three days. So when I add up all those numbers together, I should get 213,000, 213,444. That's how many people played the game. All right. The next thing we're going to target. Lost on day 1 or day 2. Okay. So does it say you're only allowed to lose once? Okay, so they can lose both as well, can't they? Okay, I'm going to start with lose. Okay, so lose day 1 is these 72,000 people here, isn't it? Okay, and that breaks up into what 2 set. But those 72,000 people don't count, do they? Because not all of them played all 3 days. Do you get what I'm saying? Some of them bailed out. They didn't play all 3 days. But out of that 72,000 people, where did they go? Only 18,000 of them actually played. So 18,000 of them actually played. Now, how many of them made it to the end? So we can go up here to the 14,400. They won. And then see these 12,690 people. What's their deal? They lost on day 1, but they played till the end. So they count, don't they? So those 12,960 people, they actually count. Now, let's go what happens when we lose on the second day. We lost the second day, and out of those people who lost both days, only 900 of them made it to the end. So that's going to be 900 people here, yeah? Now, we're going to go up to the start next. Now, of all the winners on day 1, only this amount of them played, okay? And we need them to lose at least once, don't we? So that's the goal of the question. So 51,840 of them lost, and out of that, only 12,960 of them played to the last day. So here's how many people lost 1 or 2 matches and played to the last day. I'm going to add all of them up, and what I'm going to get, I'm going to add everything in that red circle up, and what I'm going to get is 26,820. I'm going to divide that by 213,444, and I should get 745 divided by 592